On June 26, 2020, at 12 a.m. GMT, a CoSpace Rescue Challenge map was issued to iCooL participants from around the world. All participants were given 24 hours to develop AI strategies to solve the same challenge. In CoSpace Rescue Challenge, teams are required to build a real robot, develop and program appropriate algorithms and strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. Additionally, they have to search and collect objects while competing with another team's robot that is also searching and collecting objects in the same real and virtual worlds. During the challenge, the robot needs to overcome barriers, avoid traps, and swamps. If the robot successfully makes a deposit, the points of the objects deposited will be doubled. For University and U19 category, the CoSpace server will send the robot its own coordinates while the robot is searching in the virtual world. The location information can be used for the development of AI algorithms and strategy such as path planning and search algorithms. Additionally, for University and U19 categories, there are signal block zones which are surrounded by pink dotted lines. When a robot enters the signal block zone, its coordinates information will be blocked. The winner of the challenge will be the robot with the highest points.
Hi, I am Barrier Azai from Iran in RCAP CoSpace Rescue Challenge U19, and I'm going to give some details about my experience in programming and a special part of Visual Studio Code and some helpers apps to write code easier in Visual Studio. So I started Python programming from 2 years ago, and I started learning C language in Visual Studio 9 months ago in my school. Python was really helpful for my code in Visual Studio because I create some apps with Python language to get visual code from them and use them in my code. In my code with one boolean, I can use robot position to go my custom position, and I create a helper app with Python to get the position of steps. For this helper app works correctly, helper needs a map picture to choose the step path. In helper, one if code will check every time when I click somewhere on map, and that if will get a backup from mouse position and fix that with a map position and save that on one list. And I have a one boolean in Python, or def in Python, to print list every time when I add a position, and this helper will make a list from position X and position Y of steps, and I copy that list and paste that in my code. After that, with one if in my Visual Studio code, robot will go in the way that I choose, and after ending the steps, robot go from the first step in the list like a loop. I have another helper app to make zones for super objects. Super objects have a lot of points, so I don't want to miss that, and I want to take it. So if map be open, I can use that position boolean to go and pick it. But if map have a lot of traps and walls, when robots want to go and pick super object, there is a lot of traps and walls between robot and super object, and actually that's really annoying. So with zones that I wrote before, when robot and super object were in the same zone, and the robot will go and pick it. In helper, I choose 2 dots on map. In helper, I choose 2 dots on map, and helper will give me a code with position of the zone and when robots and super objects were in the same zone, code will change one variable in code, and after that with position boolean, robot will go and pick super object so easy. So and for this tournament I get a lot of ideas and to add them in my code and get my code better and better. And CoSpace really helped me to have teamwork with my teammates, and I hope all of my teammates get a good point in CS spot. And that was my experience in Visual Studio, and that's it. Bye.
Hi everyone, let's do a little self-introduction here. I am Mok Jin-won, a finalist from Yishun Secondary School, Singapore. So upon hearing the great news that I'm qualified for the finals, I felt grateful for the chance to be part of this large-scale global event. For this competition and the past few years, I have been using the CoSpace U19 platforms. I could clearly remember the first day when I started coding with Scratch 6 years ago when I was just a primary 5 student. And it's unbelievable how these years of hard work have shaped me into the coder I am today. To understand the strategies that help me come thus far, we have to go back to the basics. The first strategy in the game is the ability to navigate through the map seamlessly and reach the location that you want the robot to go. Path planning is essentially the fundamental of the whole game of CoSpace. But at the same time, it's also the most challenging and difficult algorithms to master. For this, I started off using the Dijkstra algorithm, but due to computational efficiency and the difficulty of optimal node placement in a short time, I switched to the A-star algorithm, which allowed me to use bitmap for node location via image recognition. The second strategy is the ability to maximize point collected every second, which is the efficiency of the robot. The time of 6 minutes is a short duration, and to maximize points collected, we have to reduce the time wasted on traveling and looking for the points. The traveling time is cut down using the first point from above. For the point collection, however, we have to choose whether we want to collect or go to a point by using an algorithm to predict the highest possible point achieved after the collection of this point. The robot will thus make decisions such as traveling a further distance to get an RRGGBB combination and going to blue special zone for points collection. The last strategy is the ability to cover a point area in the most efficient way. This is done through the usage of Bostrom-Verdon algorithm to cover the whole area of the point area in whichever situation, in case of a sparse area. In such a situation, the robot might spend a long time searching but will find all possible points. This is also optimized through the usage of sweeping movements to make the robot cover a larger area in a short distance, so there will not be so many repetitions of straight line movements. This is only possible through the manipulation of trigonometric calculations. The CoSpace learning experience was rocky and one filled with many anticipating challenges for me, and that which was also the primary reason why I pursued it as a hobby and started learning coding in depth. It has not only developed me as a person, as a competitor, to keep on upgrading and refining my skills, but also changed my mentality and attitudes towards life through the success and failure after each obstacle I came across. Before I joined CoSpace, I hardly had any long-term goals or motivation in life, which thus directly affected my view on my studies and future. After joining CoSpace, however, I started to understand the importance of putting oneself through challenges after challenges to hone our skills and mentality. Although sometimes there might seem to be no hope left and you feel like giving up. Through multiple tries, it's the moment that the robot is finally doing what you want it to do that make you feel like it's worth all the headaches and pain. It has been a long journey for me in CoSpace, and the most important lesson that I've learned in CoSpace is never ever give up.
And off we go! In this demo game, we will minimize any manual intervention. Red robot entered the black object area, and the black object is worth 20 points. Blue robot is searching in the blue special area. Any objects picked up in this area will double in value. Blue robot has a set of red, black, and cyan objects. It can generate a super object. Red robot is depositing. Blue robot is depositing. Blue robot has picked up a super plus object, that is 180 points. Red robot has picked up a super plus object, that is 180 points. Red robot is depositing. Blue robot is depositing. Looks like a close match. Blue robot has a set of red, black, and cyan objects. It can generate a super object. Blue robot is depositing. Red robot is depositing. Red robot has picked up a super plus object, that is 180 points. Blue robot is depositing. Blue robot has picked up a super plus object, that is 180 points. Red robot is depositing. Both robots are in the blue special area. Any objects picked up in this area will double in value. 1 minute left. Blue robot is depositing. Red robot has picked up a Super Plus object. That is 180 points. Oh no! Blue robot has fallen into the trap. Points of the undeposited objects are reset and lost. Red robot is depositing. Blue robot is depositing. Blue robot wins this challenge. Congratulations!